Good morning. I would like to say good morning to the people that are here attending in person, and good evening to all the people that are currently live streaming across Europe and Asia. Thank you very much for attending the first workshop on AI, big data, and policy. So we're very welcome to have everybody here both in person and online. I'd like to note that the event has been sponsored by the Georgetown Center for Business and Public Policy, KIET, which is the Korean Institute of Industry, Economics, and Trade, and the World Bank. The overall objective of the event today is to create a forum for knowledge spillover across the major key stakeholders of artificial intelligence. That includes academia, policymakers, and industry experts. So the idea here is to share knowledge across these key stakeholders and to learn from one another. And we think that's notably important in a current state where we have lots of uncertainty around the advances of these technologies and around the extent to which they're going to lead to disruptive effects, both inside the economy and for society. So we welcome those online and also those in person. We would like to remind everybody that there will be Q&A sessions at the end of each talk. We'll have to be quite strict with the time, so we ask that you don't ask questions during the presentation, but you hold it at the end. I would like to thank as well for the event my co-organizer, Jonathan Timmis from the World Bank, who's a great colleague and a great friend. And I'd also like to thank Andrea Moretti and Caroline DeRover, who have given us unspeakable and very helpful support for this event. I would also like to invite our keynote, which is Avi Goldfarb. I've personally been following Avi's work for a very long time, and it's influenced a lot of the work that I do today. Avi Goldfarb is a professor at the University of Toronto. He's the Rotman Chair of AI and Healthcare. He's published scores of papers on the effects of digital technology in the economy, and more recently, he's dedicated probably one of the earlier researchers looking at the effects of artificial intelligence in the economy. Not only that, he's a best-selling author, and he's recently published a book called Power of Prediction. So we're very happy to welcome Avi today. He will be speaking for 40 minutes, and then we'll follow up with Q&A afterwards. Thank you very much, Avi.
Okay. Here's the marketing. Okay. There is no shortage of hype around discussions of artificial intelligence. If you've been paying attention, I should have updated these based on yesterday. Down the road, there's maybe this is going to be a multi-trillion-dollar industry that's going to transform the world, and maybe in the process, we're going to lose our human autonomy. Daniel Kahneman said, clearly AI is going to win, and how we humans, how people adjust, is a fascinating problem. Now, Daniel Kahneman, I guess you guys know this in this room, right? He's the only psychologist to win the Nobel Prize in economics. It's a fascinating problem if you've already won the Nobel Prize, but for the rest of us, it's a little bit terrifying, right? So if the machine's going to win, what does that mean? What does that mean for the future of work? What does that mean for what's left for our organizations and our day-to-day lives? Frankly, I think underlying the hype, like on the positive and the negative, is a lot of confusion about what we're talking about when we're talking about artificial intelligence. Even yesterday, if you were watching the proceedings, you got a sense that there was this underlying anxiety that we're going to be in a science fiction world of machines that can do everything we can do. That may happen, and actually maybe there's good reasons to be thinking about that and regulating that. But that's not the technology we have today. We are not in a world of artificial general intelligence. We're not in a world of machines that we've seen in science fiction that can do everything we can do and that may or may not take over the world. What has driven the recent excitement in artificial intelligence is a very particular suite of technologies, deep learning and machine learning, that have gotten much, much, much better. What is that? It's computational statistics. That's it. Now, if we called our book Power and Prediction: The Disruptive Economics of Computational Stats, it would not have been a bestseller. But underlying it, maybe there wouldn't have been congressional meetings either, but underlying it is just prediction technology. Prediction in the statistical sense, the way we understand as economists, using information we have to generate information you don't have. That technology has gotten much better, faster, and cheaper. And so our first book came out in 2018 and suggested we're on the cusp of this massive drop in the cost of prediction. And for those of you who teach Econ 101, at least the micro version, you know the very first thing you teach is that demand curves slope downward. If demand curves slope downward, that means when the price of something falls, we do it more. And so as predictions getting cheaper and cheaper and cheaper and cheaper, we're going to be doing more and more and more prediction. Simple economics. And so what's happened is exactly that. We've started to see machine prediction in more and more parts of the economy. It started with the classic prediction problems. Maybe the classic business problem is whether someone's going to pay back their loan. And increasingly, we're using machine learning tools. Instead of some loan officer at the bank who might look you up and down and decide whether they're going to pay them back, we're using these machine learning tools to predict whether they're going to pay back your loan. In the insurance industry, they've also embraced machine learning tools. They've also embraced AI for underwriting, because they're in the business of pricing risk. They're in the business of prediction. And increasingly, it makes sense to use prediction machines to help them do that better. But as prediction's getting cheaper, we're starting to realize there's some things that we may not have thought of as prediction that can be reframed as prediction problems. So facial recognition, or recognizing a cat on the internet. How does that happen? Well, your eyes take in these light signals and they fill in the missing information of a label and a context. And as machine learning has gotten better, we've realized from an engineering point of view, it is possible to solve that with machine prediction. Medical diagnosis, also prediction. What does your doctor do when they diagnose you? They take in data about your symptoms, and they fill in the missing information of the cause of those symptoms. That's prediction. Now, we've also started to realize a whole bunch of other applications are prediction. So lesson number one, point number one, when you hear AI today, don't think science fiction, think prediction machines. Today's AI is prediction technology, and the things you learned in your econometrics class apply at scale in terms of how to use it and what might go wrong. OpenAI, their tools are also prediction machines. What ChatGPT is doing is effectively predicting the set of words and the order of those words in response to a particular query. It is a statistical engine. It's just an amazing one. We didn't used to think of writing as a prediction task, but it turns out as machines' predictions getting cheaper, we can reframe writing as a prediction task. Similarly, image generation. If you ask DALL-E for an image of an astronaut on a horse in the style of Andy Warhol, it will give you an astronaut on a horse in the style of Andy Warhol. Now, it's not that there was an image like that in the database. There was data on people on horses, there was data on astronauts, and there was data on what the style of Andy Warhol meant, and it predicted what the combination of those three things would be and provides that kind of an image. So as we're seeing machine prediction in more and more parts of the economy, we're starting to think, well, this could be really transformative. This technology might change the way we live and the way we work. And so let's look at these other technologies that transform the way that we lived and the way we worked and think about, wow, electricity is everywhere. You know, we couldn't really live the lives we live today without electricity. And so maybe AI is the next electricity. And that's why yesterday we talked about needing a regulatory body and a whole bunch of resources and attention to managing that transformation. What does that mean? What does it mean for prediction technology to change the way an organization operates? Imagine that you have a dial on the prediction. The predictions are pretty good today, and they're going to get better and better and better and better over time. At some point, the predictions are good enough that the organization can do things entirely differently. So walk through an example of a prediction that we're all kind of familiar with, Amazon's predictions about what you're going to buy. Okay? As far as I can tell, this is a recommendation engine. They write something like 1 out of every 20 times. That's extraordinary, right? They have hundreds of millions of items in their catalog, and they make a recommendation to you, and they're right 1 out of every 20 times. So for every 20 they recommend, you're going to buy one. It's extraordinary, but it hasn't changed their business model. 20 years ago, their workflow was effectively the same. Right? So you'd go to their website, they'd make a recommendation to you. They'd recommend the same thing to all of you. 20 years ago, everybody would have been recommended the Da Vinci Code. That was their #1 seller. Okay. And so you were recommended the Da Vinci Code. You decide whether you want to listen to that recommendation or not. You go to the rest of their catalog, you make a purchase, and then they send that information to the warehouse, they ship it to your door. Now, imagine turning that dial up. And so instead of this current model of you shop on their website, they're a catalog company, like Sears was 100 years ago. A good catalog company, but a catalog company. That instead of 5% accurate, they're 10, 20, 30, 50, 70. At some point, they're going to be able to do things differently. They're going to be able to, instead of waiting for you to order, they're going to have a good enough sense of what you want. They'll just ship boxes to your door. And they don't have to be right about everything. They just have to be right about enough things that it's worth it for them to deal with an infrastructure for returns for the things you don't want. Now, they may or may not do this, but they've thought about it. Here's a patent for Amazon for anticipatory package shipping. It is something they are working on. But then if you look a little closer at the patent, something's wrong. That patent is from a decade ago. And here we are a decade later, and we're not getting these packages shipped to our door. Well, what went wrong? More generally, the vast majority of US companies have not adopted AI, even today. And of those that have adopted, relatively recently, the vast majority of those said they hadn't seen a return. How can we reconcile that with the idea that AI is the new electricity? Well, a group of economists, you may know a little bit about Paul David and Warren Devine Jr. and the history of electricity. So here's a little bit about the history of electricity. Electricity, Edison's patent was the 1880s for the light bulb. Tesla's patent for the alternating current electric motor, 1890. It was clear, if you were paying attention in the 1880s, that electricity was going to be a big deal and change the way we lived and worked. But it wasn't until the 1920s, 40 years later, that the median household and the median factory in the US were electrified. It took 40 years from we all said, hey, this technology is going to change the way we operate, till it affected most people at home and at work. Well, what took so long? This is what a factory might have looked like in the 1880s. It's not a picture, it's not a photograph, it's a drawing. But what you can see in the drawing is everything's connected by these belts to a central steam engine. The factory was powered by the steam engine, and the logic of the factory, the microgeography of the factory, the workflow was determined by the power needs of the machines. What do I mean by that? Well, if you remember your high school physics, energy dissipates with distance. And so you want the machines that are the most power hungry to be as close as possible to the power source. And so that's how the factory was designed. Then electricity came along, and it was maybe cheaper than steam in some cases, maybe cheaper than water in some cases. And a handful of entrepreneurs and factory owners said, you know what? We can take out our steam engine, drop in an electric motor in the exact same point in the factory, and save 5, 10, maybe even 15% on our energy costs. And they did. But for the most part, that wasn't worth it. To save a little bit on your energy costs, it wasn't worth it to take out your steam engine, drop in the electric motor, figure out how to get electricity into the factory, deal with the fireproofing that is necessary if you have now electrified your entire factory. It just wasn't worth the bother. And so they didn't. And by 1900, less than 5% of US factories had adopted electricity. 20 years after the light bulb patent. Now, around 1900, some people started to realize that electricity wasn't just cheap power. Electricity is distributed power. It allows you to decouple the power source from the machine. And once you've decoupled the power source from the machine, you can build a new kind of factory. And that's what Henry Ford and others discovered, which is that electricity means a different kind of factory. It means the logic of production can be determined by the logic of production. What do I mean by that? Inputs in one end, outputs out the other, modular production process. You don't have to worry about where the machines are according to the power source. You just figure out what's the most efficient way to get from inputs to outputs. That led to the quintessential 20th century factory, and that led to a change in the trajectory of adoption, and over time a massive increase in the use of electricity in factories. Similar things were happening in homes in terms of the redesign of how we live at home. This is Warren Devine Jr.'s Journal of Economic History paper, and then reinterpreted by Paul David to say, hey, maybe that's happening with the computer. That's what he said in 1990. Eric Brynjolfsson, Daniel Rock, and Chet Syverson said, hey, maybe that's happening with AI, okay, in chapter 1 of our Economics of AI conference volume. So we're in these between times, right? Feels like we're in the 1890s. We can see the potential of the technology, but we haven't quite figured out what the organization of the future looks like. And so when we look at the vast majority of the AIs we've seen today deployed in businesses, they're not about reorganizing how you operate. They're point solutions. They're like taking out the steam engine, dropping an electric motor at the exact same point without messing with the workflow. And then the upside is necessarily limited to doing things a little bit more efficiently. So you think about predicting whether people are going to pay back their loans. Well, instead of some human process, you're dropping in a machine process and you're making it incrementally better. Amazon's recommendation engine, rather than saying, hey, everybody just buy the most popular product, we have some targeted things to different people. It makes things a little bit better, a little bit more efficient, but it doesn't really transform the way we do business. And that's how we can start to understand, even among those who have adopted machine learning tools, who have adopted prediction machines, that the payoff remains pretty limited. So much of the time what they're doing is identifying an existing prediction within their workflow, taking out some human process and making that, adding in a machine at the same point, and making it 5, 10, 15% more efficient. And the potential upside is inherently limited. But the transformational opportunities for AI are doing more than the same thing a little bit better. They're about developing system-level solutions, rethinking how you can deliver value and how you can operate. So what makes AI different from electricity or computing or whatever other general purpose technology you might be thinking about? AI is useful. Predictions are useful because they help you make decisions. And it's decision making that's a big deal. Not the prediction, but the decision. In fact, if someone gives you a prediction but doesn't know what decision it's supporting, the prediction is useless. Predictions help you make better decisions. Right now, when you make a decision, though, you have a prediction that happens in your head, and you have what we call judgment, knowing which predictions to make and what to do with them once you have them also. And those things are combined when you decide what to do. What AI does is it decouples the prediction from the rest of the decision. So we now have a machine providing a prediction, but a human decision. In order to unpack what this means, I'd like to go back to science fiction. I don't know if you've guys seen the movie I, Robot. Some of you maybe not. It's a fine movie, but it's excellent science fiction. Okay? And here's what makes it excellent science fiction. So there's this flashback scene. Will Smith is the protagonist, and he hates robots. Okay? And there's this flashback scene about why he hates robots. He and this little girl are in a car accident, and they start sinking into a river, and it's pretty clear they're both about to drown. And then a robot comes along and saves him and not the girl. And that's why he hates robots. Now, okay, science fiction admittedly, but because it was a machine, he could audit it. He could figure out, well, why did the robot save me and not the girl? And it turned out the robot predicted that he had a 45% chance of survival. And the girl The girl had an 11% chance of survival, and that's why the robot saved him and not the girl. Predictions, 45 versus 11. But then Will Smith says, but 11% was more than enough, and a human being would have known that. Well, that's not the prediction. That's judgment. That's knowing what we value. And in an era of prediction machines, that remains inherently human. Some team of engineers, fictional engineers in this case, programmed that robot some time ago to say a life is a life. That's the judgment encoded in the machine that drives the decisions the machines make. It's not really a machine decision. It's a machine prediction, 45 versus 11. And then there's some team of engineers, some team of humans who said a life is a life, and when deciding, you go with the 45 over the 11. Now, outside of science fiction, we're starting to see headlines suggesting machines are going to decide whether we get jobs and whether we keep jobs. Machines are going to predict who is going to succeed based on some criteria that humans input into the machine and based on some other criteria on defining whether it's above some threshold of what success means. So when you hear headlines like Amazon automatically tracks and fires warehouse workers for productivity, okay, which was a headline from a few years ago, or more recently, AI is starting to pick who gets laid off. That's not the right way to think about it. The right way to think about it is AI is enabling a centralization of the decision rights on who gets to be hired and who gets laid off. It's a power change within the company, because instead of individual HR managers in every warehouse or on the ground deciding on performance reviews and who to bring in and who to let go, it's presumably a team at headquarters who says, you know what, this is how we define success in our organization. This is the metric we can use. And if somebody is above or below some threshold, then we're going to define that threshold. We're going to tell the machine how to build that threshold, how to generate that threshold. And then we'll have the machine automatically send a note saying, at least according to these stories, you're going to be let go. Now, the emphasis there, it's not that humans are empowering machines. It's that machines are empowering some humans over others. What AI does is it decouples the prediction from the judgment, which can enable different people to make decisions. It's not always so dark about a centralization of power. Sometimes it works in the other way. Okay. So I don't know if you remember a few years ago in Flint, Michigan, there was this water crisis. And you don't want lead in your water. And about 20% of houses in Flint had lead pipes. And so the city got some funding and set about trying to replace the lead pipes that existed with pipes without lead. Now, the problem was there were no records of which pipes had lead and which pipes were copper. And so without records, they essentially, to figure out if your house had lead pipes into it, they had to dig it up. At that point, it was pretty easy to replace, but it cost time and money. And so these two professors at the University of Michigan said, you know what, this is a machine learning problem. Right? This is an AI problem. We can predict which houses have lead pipes. And they built a prediction machine, and that prediction machine was great. So instead of only being right 1 out of 5 times, which was the base rate in the city, they were right 4 out of 5 times. So 4 out of 5 times they told the contractors to dig, that contractor found lead pipes. And it was fantastic, and thousands of people drank safe water faster than they otherwise would have. But the story didn't quite end there. What happened was some people in the city said, well, wait, how come the people the street over, they're getting their pipes dug up, and my pipes aren't dug up? That doesn't seem fair. I want to be reassured that I don't have lead pipes. And it turned out many of those people were voters. And they were the people, and they started complaining to their city councilors and saying, hey, city councilor, I voted for you. How come we have this unfair system listening to these eggheads at the University of Michigan? We should be starting house by house, street by street, systematically in Flint, Michigan, with my house. And the city councilor said, hey, you know what, why are we listening to these eggheads at the University of Michigan? You're right. we should be doing something more systematic, starting with the people who are most worried about it and talking to me. And that's what happened. The city councilor said, wait, this AI that's helping all these people who have lead pipes, who have older, less expensive houses, effectively, forget that. Let's take the power back and go systematically wherever we want. And the success rate plummeted from 80% to 20%. But the story didn't end there either, because the judgment here is clear. When the prediction and the judgment were combined in your head, hey, we don't really know which pipes have lead, well, let's go systematically to these houses and then these houses, fine. But once you have a good prediction, it's clear what the wrong call is. And once it's clear what the wrong call is, some people from the city sued, and the courts decided with them and said, no, 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 you actually have to listen. It is the law in Flint, Michigan, to listen to those professors' algorithm. And then they built it into a company, and it's now in dozens of cities around the country and around the world. It's a change in power from the city councilors to the people who ultimately were drinking unsafe water because of AI. All through this decoupling. Now, this is suggestive of one of the biggest sources of resistance to adoption of new technology generally and to organizational change, and that we've seen sort of with AI. So a lot of what you hear is we shouldn't be using machines because the machines are biased. Okay, that's a common theme. It was part of the what we heard yesterday, and absolutely we should be worried about biased machines. Okay, but what's nice about biased machines is we can audit them and figure out they're biased. The real resistance might come from those who benefit from the current system. Give me an example. So I guess I'm in the United States. So I don't have to explain how baseball works. But if you think about it, it's kind of crazy what we ask human umpires to do in baseball. Okay, so there's this piece of wood on the ground. It's like this big. And there's a ball that's about this big going 95 miles an hour. Okay. And a human has to say hundreds of times over the course of 3 hours whether this ball going 95 miles an hour is on top of a piece of wood about this big and between somebody's shoulders and their knees. In every 5 minutes, the height changes, and so it's different height between shoulders and knees. That's insane that we're asking any humans to do that. That is not a human task. And it turns out human umpires are pretty good at it, and so the game works. Okay. But about 20 years ago, Major League Baseball realized, well, the humans aren't that good at it, and they make mistakes, and a machine could probably do better. And they tested out a new system with a machine calling balls and strikes. And the system worked. It was, under objective measures, better at calling balls and strikes than the human umpires. The umpires didn't like it, but that wasn't going to be the main factor in Major League Baseball's decision. But it turned out the star players didn't like it either. Why? Well, Barry Bonds was the best hitter in the league at the time, and he hated this system. Why did he hate this system? With human umpires, if Barry Bonds didn't swing, the umpire called it a ball. He was the best hitter in the game. Who am I as an umpire to say whether it's a ball or strike? Clearly it's a ball because he didn't swing. Okay? Not quite that way, but the umpires were very clearly biased in favor of the star players, the star hitters, and the star pitchers. And when we went to a fair system, the superstars, Barry Bonds on the hitter side and Curt Schilling on the pitcher side, they did worse, and they didn't like it, and they complained. Curt Schilling actually took a baseball bat to one of these cameras and destroyed it. Okay. And Major League Baseball ended the experiment. The people in power, the people who controlled decisions in Major League Baseball, the most important people in the game, didn't like the fair system, and they were the ones who resisted the automation. More generally, there's this challenge in using prediction tools there's this narrative in using prediction tools that we shouldn't use prediction machines because they're going to be biased. But then you got to take a step back. And Senthil Mullainathan pointed out, well, why are the machines biased? The machines are biased because Because humans are biased. They're trained on human data. And so the idea that we should drop the machine and stick to the human kind of misses the counterfactual. Marzi Kassemi is a computer scientist at MIT, says it's not that I believe so much in machines, but humans are awful. And so like we got to be able to do better than that. So like Sendel, as an example, so he ran the resume experiment, famous resume experiment from about 20 years. Wow, there's a lot going on about 20 years ago. With Emily and Greg versus Lakeisha and Jamal. And he sent resumes to a bunch of potential employers and changed the names on those resumes randomly. And it turned out Emily and Greg got more callbacks. Okay. And so that proved discrimination in the workplace. That study took hundreds of hours, thousands and thousands of dollars. And even after the fact, they didn't know which employers were discriminating. They just knew that some employers were discriminating. Fast forward 15 years, he does another study of looking for discrimination in algorithms. And it takes him a 2-hour simulation. And he figures out, hey, that machine is discriminating. And then they figured out how to improve it. Right? Much more straightforward, simple, not just, so he knew it took a lot less time, a lot less effort, and it was improvable. Underlying this is just this recognition that what are the machines for? They're useful for decision making by decoupling the prediction from the rest of the decision. And a lot of the resistance is going to come from this change in power. Right? When new people are making decisions, new people have control over decisions. And that presents opportunity. But the people who used to be doing well might not like it so much. Now, the last thing to be thinking about, at least in the course of this first hour of this conference, is should you worry? Should you worry about your job? Should you worry about your organization? How does this all fit into the workflow and the processes that you're part of? Well, trying to understand what aspects of your workflow are really about success. So this is Seoul Incheon Airport. It is by many accounts the best airport in the world. And what this airport and Singapore and Beijing, the best airports in the world, have in common is they have lots of natural light, beautiful spaces, they're multi-billion-dollar structures, they have fantastic restaurants, shopping, some even have museums and theater. They seem like wonderful places to hang out. And yet, almost every one of you would rather fly through this airport. This airport, this shed, is how the super rich fly. This is the private terminal at Boston Logan. The rest of us get to fly through these multi-billion-dollar structures, and the billionaires fly through a shed that costs maybe a couple $100,000. How does that make sense? Well, think about the mission of Seoul Incheon. The mission of Seoul Incheon is to ensure smooth air transportation. But the vast majority of what they do is driven by the fact that they fail. Right? Those restaurants are there because you don't just walk on the plane and take off. The shopping is there and the beautiful spaces are there because you actually have to spend time at the airport. And nobody wants to spend time at an airport. So when you're thinking through disruption, when you're thinking through, is this technology, this next generation of technology going to destroy my workflow, change the way I need to operate, lead to the potential for disruption, think through how much of what you do is driven by failure. How much of what you do is not about delivering on your mission, but about compensating your stakeholders for the fact that you fail to deliver on your mission. In the airport example, imagine if you had a good prediction about how long it would take to get to the airport through security into the gate. Well, then you just walk on the plane and take off and spend no time at the restaurants, the shopping, the theater, the beautiful natural light. You just walk through like they do in the private terminals. Now, second example of this. So imagine you go to your doctor. Your doctor takes in looks at your blood work, looks at your history, et cetera, and says, well, there's a 5% chance something catastrophic is going to happen to your health over the next year. If that happens, don't worry. We're going to give you $500,000. That's not how healthcare is supposed to work, right? The doctor's supposed to say it's 5% chance something catastrophic happens to your health next year. Here are the treatments to reduce the chance that that's happening. Okay, luckily, healthcare doesn't work that way. But insurance does work that way. That is exactly what happens. Your insurance company has all sorts of fantastic data about the likelihood that something catastrophic is going to happen to your house over the next year, to the point where they can price that risk. And they say some people have higher risk because there's likelihood of leaky pipes. And some people have higher risk because they're likely to have an electrical fire. And they say, oh, don't worry. We're going to give you peace of mind against the catastrophic loss by giving you some money if that happens. It's better than nothing. But that's not peace of mind. Peace of mind would say, look, we have all this data about your house. We know the reason your insurance is expensive is because there's a high likelihood of leaky pipes. And we can install this sensor for $25 that detects those leaky pipes and shuts down your water if your pipes start to leak, so that you don't have that disaster. And by the way, that $25 for most of the people who are at high risk of leaky pipes is a lot less than the extra insurance they pay every year. This is technically possible. The hard part is not the prediction. And we've been working with an insurance company to try to make this happen. But it turned out, well, there's all sorts of other hard parts. And this is related to, what are the challenges in technological change in bringing new systems into organizations? The way many insurance companies operate is underwriting is the center of power, right? They're the ones who provide the business of prediction. But what this is about, with this tool, is behavior change, right? You got to get people to adopt a new sensor, put it into their house. That's a marketing task. And in many insurance companies, marketing is not a center of power. In fact, marketing doesn't even have access to the data that underwriting has, not because of any regulatory reason, just because underwriting doesn't want to give them the data. Right? It's a core aspect of where underwriting generates their power and their privilege in the organization. And so we worked, and finally we got marketing and underwriting to work together, and they started to agree. And then we had a different problem, which is that marketing wasn't called marketing. It was called sales and marketing, where sales was on the top. And in most insurance companies, and certainly in this insurance company, sales were compensated by commission. And so the last thing they wanted was a new product that was going to reduce prices in order to reduce costs. And so we faced a whole nother set of challenges. Whenever you're doing big picture changes, when you're doing things beyond looking at your existing workflow and making one little piece more efficient, you're going to create these challenges in changing who gets to decide what. And that will require new organization structures. And that's where a lot of the sort of factory of the future ideas apply. You're looking for places where you fail to deliver on your mission, but then you got to think through, how does that new organization look like? What does that new organization look like to enable that kind of coordination? Because decisions don't occur in isolation, right? Any big picture decision that's trying to change the system for your company is going to require coordination with other parts of the company. I'll give you an example of somebody who managed to overcome this challenge. It's my last story. Okay, so this is a boat. Okay, it's a particular boat. It is the boat that won the first America's Cup race in the 19th century. So it's a sailboat. And the America's Cup race is like the main sailing race. I don't know if there's... So what's happened, even though we don't really sail for transportation anymore, there's been incredible innovation in sailing over the past 150 so years. Because this, turns out, is also a boat. Okay? This is the sailboat that won the most recent America's Cup race. It looks a lot different from that first boat. There has been a ton of innovation in boat design since the 19th century, to the point where this is barely, they call it a boat, but really it's a flying machine that's connected to the water by this little pole. Okay? There's been incredible innovation in sailing. First, it was through wind tunnels, where they could simulate the impact of being out in the water, but without having to go out in the water. Then it was through computer simulation. They realized they understood enough about fluid dynamics about 25 years ago that they could simulate new boat designs to figure out how to get even faster. So there was incredible innovation in boat design. But to win a sailing race requires more than a great boat. It requires great sailors. There's two types of decisions, and they need to be coordinated. And the innovation in boat design was always limited by the fact that we humans learn very slowly. There was only so much experimentation we could do with humans who needed to eat and sleep and rest and all that. Right? For a human to do something that takes an hour, it takes us an hour. For a computer to do something to take an hour in simulation might take a second. And so Team New Zealand, in the run-up to the most recent America's Cup race, realized we could also simulate the sailor and not just the boat. And so they did that. And through a process they called digital twins. Okay? This is economists, we would have just called the simulation, but digital twins is a better label. And the idea of a digital twin is a really sort of a very detailed simulation that captures more of the core processes than you would think in your structural econometric model that might simulate mergers at the FTC. Okay. But the underlying idea is the same. And what they did is they simulated not just changes in boat design, but changes in sailing. And what they discovered is there are certain boat designs that would be more effective if we also change the way we sail, the sailing strategy. And they worked. So there were some new boat designs that worked with new sailing strategies. They implemented them. And it's not the ultimate test of whether it worked or not, but they did win the race. Okay. So right now, as I said, we're in these between times. We can see the potential of the technology, but we're still kind of stuck in the 1890s. What we're trying to discover is what this organization of the future looks like. How do we overcome the resistance to the changes in power? And how do we design coordinated decision-making to create, to take advantage of all the technology has to offer? It's time for, I think we have time for questions. Thank you.
Thank you very much. That was excellent. So we've had lots of people online. More than 300 people have been watching you online. We have nearly 100 people here. People have submitted questions when they registered online as we're going, and I'm sure people in the audience have many questions. We have about 15 minutes. We won't have time to go through everyone. But what we'll do is I'll take a couple from people online, and then we'll go for a couple in the audience, and then see if we've got time to take a couple more. But if you could be sort of brief, if you don't mind.
I will do my best.
So one question that came up a lot online was about skills. And what skills do people need to be able to work with AI and benefit from AI? And related to that, how do we need to rethink education policies, thinking back to schools and so on? And this has been raised by Enrique Fernandez from the government of the Dominican Republic and Jennifer Butcher from Georgetown University.
Okay. Oh, I got to answer short. So there's sort of two broad buckets to think about answering that question. One is statistical understanding is now table stakes. And so that should be part of everybody's education. We need to just understand how probabilistic reasoning works. Okay. It hasn't been part of the core curriculum up through high school for whatever reason, but it should be. And there's lots of ways to do that. So even to the point where none of us understand, I imagine, how our computers work. I don't know, maybe a couple of you do, but do you really know how we turn essentially light switches into all the stuff that your computer does? Probably not. Okay. But you have some intuition about the deterministic nature of how computers work, as in when you give it instructions, it follows them, and things tend to be repeated, and when something works once, it's likely to continue to work, things like that. And there's lots of ways we learn that. Some of that we learn in school, and some of it we learn simply through playing computer games. We learn the non-playing characters in computer games tend to do the same loop over and over again, at least in the pre-AI era, and that helps us learn how our computers work when we have to deal with them at work. And so the same kind of thing in AI. So part of that's going to be curriculum, but part of it is just going to be as we grow up and learn to interact with AI systems to just deal with the probabilistic nature of them. So that's like category 1 is stats. Category 2 is I'm excited about the potential of this technology to empower people who've been left out. Okay, and that's not usually the narrative you hear. And what I mean by that, a lot of people's job prospects are restricted, for example, by their ability to write. Okay, so they might be very good at some particular skill, but it's hard for them to get business because they don't know how to communicate with a customer. But now, with if they can log into ChatGPT and say, hey, I want to write a letter to a client, this is what the price is going to be, blah, 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 it'll write a very clean letter. And it's not a beautiful letter, and it's not an elegant letter, but that doesn't matter. It's a clean letter, and that'll allow them to get the value out of the other skills they have. So I think there's a, everybody sort of needs to understand basic probabilistic reasoning, and then some of the skills that we've emphasized, writing a 5-paragraph essay, aren't that useful anymore. And instead, we've got to think through the complements to writing that are valuable.
Great. So I'll take one more online, and then we'll get a microphone to people. So raise your hand if you have a question after this, and we'll get a microphone to you in the audience. So related to that, and people being left behind, several questions were coming through thinking about countries being left behind, particularly developing countries. We have people watching from all around the world. This question was raised by Pho Hong Min in Vietnam Academy of Sciences. There's Fabrizio Zanzi from a university in Ecuador. Farhan Roslan from a research institute in Malaysia, and they want to know how can developing countries benefit from AI and big data? Or will all the gains necessarily concentrate in the US and Western Europe?
So similar to the split there's 2 ways to think about the gains. There's the people who are developing the tools, and if the future's like the past, there's reasons to expect those gains to be largely in developed countries that are at the cutting edge of technology. But a lot of the benefits of this particular technology could be to places where the prediction tasks the machines can do are rare. Okay, what do I mean by that? So think about in medicine. Okay, so what makes doctors particularly special in the medical system is that they diagnose. Okay, so the nurses actually provide care. Pharmacists are the ones who actually provide the medicine. The doctors diagnose, okay, and provide a treatment plan. Imagine a world where we can have prediction machines, because diagnosis is prediction, right? So the machines can do the predictions at scale. Okay. Well, that should be wonderful for anybody who doesn't have access to a doctor, but might have access to some other medical professional who could work effectively with a prediction machine in order to treat patients better. So anywhere where you have a lack of doctors, but some other local medical professionals, those medical professionals can now be much, much more effective than they could be before. And so I think that in lots of industries, you can imagine that, hey, how many people are unable to participate in the global economy because they don't know how to write in English? Okay, well, now everyone can write in English, so no problem. On the flip side, it's kind of like the story we heard on the internet, but it's a little bit. But now that connectivity is combined with the ability to communicate and grow.
Great. So if you've got a question in the audience, please raise your hand, and we'll get a microphone to you if you just introduce yourself first. Yeah, Elwin.
Yes, hello. My name is Elwin Davis from the World Bank. First of all, thank you so much for this talk. That was really, really enlightening. I've got a question, no surprise, from the World Bank coming out also about scales, because that is really kind of what people are kind of wondering, kind of how can we equip people with the right skills. And particularly kind of you're describing kind of the decoupling between prediction and judgments. But to what extent, and many kind of workers and entrepreneurs, they need to be both. To what extent being good in judgment is also determined by the experiential, or kind of the experience you've had in being a good predictor. So for example, if you need to write something and you need to judge a good piece of writing, it helps to be a good writer. But the returns of becoming a good writer are now decreasing because of artificial intelligence, because if you're a bad writer, you'd rather just kind of use the AI to learn that. So kind of what does that mean for kind of learning going forward?
Okay.
Thank you.
So I'm not an education specialist. I just want to sort of, but in terms of the abstract thinking about it as prediction and judgment, predictions now being done by the machine, does that mean humans are going to get worse at the compliments? Doing things the way we always did? Yes. Okay, what do I mean by that? Right now we train lawyers by having them do a whole bunch of prediction tasks and read lots of documents and do just redact stuff, and then they get better at understanding documents. That's probably not the most efficient way to train people. It's just a way to train people while still paying them. And it's not obvious why the best way to learn how to critique writing is to write. So we know in lots of other contexts that's not, the best way, movie critics don't make movies. Okay. Book critics often don't write books. Again, most of us who use our computers and use them as tools very, very well have no idea how they work under the hood, and we don't do that arithmetic. So I think we do need to rethink what training looks like, and that's going to be context specific. So a general is going to point it, but a lot of it is going to be practice with decisions. And because prediction and judgment were combined in decision in the past, that involved practice on the prediction side. But we don't need that anymore. We just need to give people practice on the decision side with feedback, and which would be standard pedagogical processes. Great question. Thank you.
Fabio.
Hi, Avi. Thank you. Great talk. Really enjoyed it. Fabio Luzzi from Tapestry. So I have a quick question. So going back to your analogy of adoption of electricity at full scale from the 1900s, so going from just replacing the central engine to an electric engine to redesigning the entire factory, and then taking that, scaling back to the reality of a private company that know it will be beneficial for them to transform. What would help to accelerate that? Going from just changing the central engine to redesigning the organization.
Okay. Yeah. So the starting point is rather than focused on the technology, focus on what you're trying to do as a business. So think about like the thought experiment that I do in the classroom is, in executive classroom is, imagine your business being perfect and serving your customers as well as you possibly could. What does that look like? And then you go backwards and try to think, okay, well, in what ways aren't you doing that? And then are there ways that machine prediction might help you get there? And then the last step is, okay, what are the machine predictions that you can do now that over time will learn to get good enough in order to build that new organization in the future? So, but the starting point has to be transformative change. And the reason is, and I'm sure you've had experience with this, that if so many companies say, I'm not adopting AI because the cost of the data is too complicated and getting it all working and all that. And we talk about this, it's not just the data scientists, but it's the software engineers, et cetera. It's only too costly if the benefit is small, right? So when you do, if you can see a huge payoff, if you can see a multi-billion-dollar payoff, you'll be willing to spend hundreds of millions of dollars on doing something. But if the payoff is only 10 million, then it's probably not going to be worth it to invest in a $100 million data system. And that's sort of an underlying challenge.
Okay, I'll take one final question online,
okay.
And then we'll have to wrap up, I'm afraid. So apologies to everyone who we didn't get to answer all your questions. So the final one is not an easy one. It's been raised by several people, including Mingjung Kang at the KIET, Syed Shah from the World Bank, Poona from UNDP China, and many others. Essentially, do we need to regulate AI, and won't we just stifle innovation if we do this?
Okay.
No pressure.
20 years from now, I am confident there will be AI regulation. I have no idea what that regulation will look like. The push to regulate comes from a good place, right? They're worried about technological change. They're worried about the impact on jobs, worried about bias. There's there's reasons to worry. At the same time, there's reasons to worry about the regulation. And I'm an IO economist. And so the big worry that I think about is, well, why were, the biggest tech companies in the world are pushing for regulation. Maybe that's a statement about regulation is going to reduce competition. And so we are in this great situation right now where there's a new technology that's come about, and there's lots of entry. Yes, we have a leader, but that, the leader as of 2023 doesn't have to be the leader as of 2028. But if we create all sorts of barriers to entry, then maybe that'll lock in the current power structure. So I think there's some AI regulation is coming. The thing to be careful of is, as we move toward that, to make sure we don't just entrench the dominant tech companies into their current positions.
Thank you. So if we could all just thank Avi, give him a round of applause.
Thank you.